Hi everyone. In yesterday's practice, you were working on solving systems of equations by elimination. And so really in today's video, we're going to be using the same method, but the problems that we look at are going to be a little more complex. So remember, when we're using elimination, the idea is that sometimes we might need to multiply an equation by a number to make the coefficients and really the variables cancel. So if you remember back to yesterday, most of the time we were just multiplying by a -1 to get one of the variables to cancel. However, that is not always going to work, and so for some problems you're going to have to choose the best constant for the multiplication. So you're going to have to decide what to multiply by to make this happen. So let's look at this example here. So we need to solve using elimination, which means, if you remember, we need to get rid of Now, if I look here, remember we said we need one of the coefficients or the coefficients of one of the variables to be opposites. So here you can see the coefficients of x are 2 and 4, which aren't opposites. Here the coefficient of y is 1, the coefficient of y is 11 here, and those aren't opposites. And you can see that just multiplying by a -1 isn't going to get us what we need. So I'm going to focus on the coefficients of x. On my first equation, I'm going to distribute the -2. So a -2 times a positive 2x gives me a -4x. A -2 times really a positive 1 is going to give me a -2y. And on the right side, a -2 times a -9 times a -2 is a positive 18. So that's my new top equation. My second one, I'm just going to leave the same, so I have 4x plus 11y equals 9. So now when I do -4x plus 4x, remember we always add vertically, those are going to cancel, my x's go away. -2 plus 11 gives me 9y, and then 18 plus 9 is going to give me 27. So now to solve for y, I'm going to divide by 9 on both sides, and y equals a positive 3. So now that I've got my y, I'm going to substitute that in. I'm just going to choose the first equation. I'm going to substitute that in to solve for x. So now I know that 2x plus, remember instead of y, we're going to substitute the value we found, which is 3. Equals -9, and we're going to solve this equation for x. So I'm going to subtract 3 from both sides. So 2x is equal to a -12. I'm going to divide by 2, and x is equal to -6. Now remember, I'm going to make a note here that a solution to a system of equations is an ordered pair. So you need to remember that your answers to any kind of system of equations should always look like an ordered pair. It means we need parentheses, then your x-coordinate, and your y-coordinate. So in my case here, my solution, my x-coordinate is -6, my y-coordinate is a positive 3, and that's my solution, the ordered pair. All right, let's go ahead and do, I think we'll just do one more. All right, so now we're looking at number 1. Okay, we're going to solve the linear system using elimination. Again, we know that means we have to get rid of one of the variables. So if I look at my system here, I have 6x plus 5y equals 19. My second equation is 2x plus 3y equals 5. And so I need to figure out how to get one of those variables to cancel. So if I look at my coefficients of x, I have 6x and 2x. Now this seems like a good one to work with because I know I could make this coefficient a -6 by just multiplying by a -3. So that's what I'm going to do on both sides. I'm going to multiply. That means I'm going to leave my first equation the way it is. So 6x plus 5y equals 19. My second equation, -3 times a +2 becomes a -6x. -3 times a +3 becomes a -9y. And then 5 times a -3 is a -15. So now my x's cancel. That's what I was hoping for. I needed to eliminate one of the variables. I have 5 plus a -9, which we know is just the same as subtracting. So I have a -4y, and then 19 minus 15 gives me a +4. So I'm going to divide both sides by a -4, and y is equal to -1. So now I can go back to my equation. I'm just going to pick the first one, and I'm going to substitute -1 for my y value. So I have 6x plus 5 times, now again, instead of y, I'm going to put in the -1 and set that equal to 19, and now I can solve. So I really have 5 times the -1 is -5, so 6x minus 5 equals 19. I'm going to add 5 to both sides, and I get 6x is equal to 24. To get x by itself, I'm going to divide both sides by 6, and x is equal to 4. So remember, we said our solution to a system is an ordered pair. So I need my parentheses. My x coordinate is 4, and my y coordinate is -1. Now, I'm going to go ahead and check this one. I should have done it in the first one, but since I've got plenty of space here, I'm going to check. So for my check, I'm going to take my first equation here. So 6x plus 5y equals 19. So instead of the x, I'm going to substitute 4 plus 5 times my y value is -1. And I hope, if I'm correct, that should be equal to 19. Oh, sorry, let me move this over. So now I've got 24 minus 5. Again, I would highly recommend putting this all into your calculator. If you type that in, 24 minus 5 does give you 19. So we know it's a solution for the first equation. We still have to check that it's a solution for the second one. Now when I'm checking, I'm going to ignore this times the -3. I'm going to use the original equation. So I'm going to do 2 times my x value, which is 4, plus 3 times the y value, which is a -1, and that hopefully is equal to 5. So again, I'm going to put this whole expression on the left side into my calculator. I'm going to get 8 minus 3, which is 5. Since my solution works for both equations, so in other words, this point is a point on both of the lines, I know my solution is correct and I am done. All right, so we will stop there and we'll go over the next 2 examples in class tomorrow. All right, make sure again that you have good complete notes. If you need to, go back and watch anything that you didn't quite understand, and I'll see you back in class. Thank you.